Hello, good morning, everyone. Welcome to AI Conference in Saudi Mobile Show. Our first session will be presented by Dr. Mashaael Almuashi on role of AI in solving the optimization problem. Hand it over to you, Doctor. Please continue.
Assalamu alaikum wa rahmatullahi wa barakatuh. This is Mashaael Almuashi. I'm assistant professor at King Saud University in the College of Computer Science. Today I would like to give you my workshop entitled The Role of AI in Solving Optimization Problem. So first of all, I would like to congratulate King Salman and Prince Mohammed bin Salman and all the Saudi people in the National Saudi Day. I'm so proud that I give my workshop in the first workshop in our National Day. This workshop is a service for my country, and it's one of the work toward our vision to 2030, and hopefully we all together succeed the vision and improve our country in the development. Now I will starting my presentation and outlining the main point we will cover in this talk. I will give a little introduction about this talk, and then we define the optimization problem for the audience who didn't know about the optimization problem. Then I will giving an example of real world optimization problem, and the main core of our talk, the optimization method and technique based on the AI technique. And I will give a real application of AI to solving a real world optimization problem. And finally, we list some recommendation and potential research area in future. The real world optimization problem actually facing a challenge when trying to solve it. There is a lot of the method that proposed in the literature review to solve or address tackling just optimization problem. Actually, we need to find the optimal or near optimal solution, and this is not easy task at all. There is a lot many optimization problem, intelligent algorithm, as I said, propose. Some of them is very successful. Some of them is still acceptable. In this workshop, we trying to focus about the AI algorithm that propose to solving just optimization problem. And we wanted to highlight the most successful intelligent algorithm and mention about their application. Okay, what is the optimization problem? What mean by optimization problem? The optimization problem is something real world problems. We find it in everywhere, in every domain, in every field. We find it in the airport. We find it in the stock market. We find it in the computer processing, in the building, in the city, in the animal life. This is optimization problem. So to be in details, optimization problem in the computer science defined as the problem of finding the best solution for feasible solution. What we mean by that? For example, we have need to find objective, and I will discuss this later in the next slide. And we want to find that the solution that's solving this objective. Generally, optimization problem divide to two types. Depend on the variables dealing with. If the dealing with the continuous variable, it will be the continuous optimization problem. If we're dealing with the discrete variable, it will be a discrete optimization problem. One kind of discrete optimization problem is it the computational optimization, and which is usually scheduling problem, timetabling, allocation problem. This kind of problem is put on the compatible optimization problem. To make it more clear what meaning by optimization problem, I will give you an example, and this is a typical example: buying a car. Okay, so sometimes we have one objective when we have buy a car. Sometimes we have a multiple objective or many objective. So we mean a multiple objective, we have only two objectives. So now we need to find the value or variables to lead us to our objective, or what we can call it optimal value of the function, whether minimum or maximum objective. So the example, let's go to our example about the buying a car. So when we usually buy a car, we have some objectives. One of the objectives, we need to buy most comfortable car, or less cost, or we need to have both, but we have compromise between two objectives. This is a typical kind of multi-objective optimization problem. So how we find the best solution, how we can solve this problem. Here our talk, we use some technology, especially that based on AI, and we find our optimal or near optimal solution. So where the optimization fit in the AI? Sometimes I remember I meet one colleague working in the same my area, optimization problem, and we were talking about AI. So my friend asked me, we're talking about AI and how it's trendy in this era, and he told me the optimization is we can categorize as AI. I argue with my friend and I tell me optimization is AI. So some people argument if optimization different field, or optimization is a branch of AI. If you are looking about this figure, we can see that artificial AI is really wide domain. It's including a lot of branches. Maybe the most famous branch is machine learning. Usually, when we mention AI, it's come machine learning with it. But as I said, it's a very wide branch. We have a lot of branch. All of them belong to the AI. One of them is planning and scheduling and optimization. And this is proof optimization. It's one branch of the AI. It's not another technique that correlate with the AI technique. This is AI technique called optimization to solving in particular optimization problem. So what is the most optimization AI-based method used? In this talk, I will talk about the most common. Maybe I can cover all the optimization AI-based method. For the interest audience, I recommend it to go to the reference at the end of my presentation if we need to go further in this area. So I will talk about the artificial neural networking, swarm intelligence. Then I will discuss the evaluationary competition, including genetic algorithm. The artificial neural networking usually apply to solve some machine learning problem or optimization problem. In this talk, I will just focus about the optimization problem. So artificial neural networking, it's the simulation for the human or the normal biological neural networking. There is many area apply on this method. Sometimes networking, because the simulation between the distributed networking in the biological neural networking, they use the same concept when they try to design the distributed networking. Another area are also using the model, the biology neural system, also to develop some powerful application. The common example in the optimization try to solve the short path or find the minimum cost per allocation problem. Also, if you want to talk about artificial life, we can find it in many other domains. So what we mean by artificial life? It's as defined here is attempt to better understand the real life in silico modeling of entity we are aware of. The famous artificial life is breed flocking. This model proposed by Rayond and including a bird iode or the set of the bird is simulating the moving of the national bird. It's depend on three sample rules. It's coming from the nature. Separation. What do you mean by separation? That the entity or the bird of flock mate separate and everyone is coming to the different location. Alignment would mean the all the flock mate going to the toward some point or some location. Cohesion mean we going move toward the average position of the local flock mate. Based on the three sample rules, it's used and applied to finding the optimal solution. This is simulation about the biode by Great Lund. Here we have the flock mate, and if we run the simulation, we find we apply the three sample rules, and they moving toward the some location or the optimal location. Now I will move to talk about swarm intelligence, and this is another method based on AI. The famous method is ant colony optimization and particle swarm optimization. Ant colony optimization, it's a simulation for the ant moving when searching for the food. The ant trying to find the short path when searching for the food. We simulate this is movement and apply it to solving the short path optimization problem. If we are looking for this graph, we find here the ant usually taking the shortest path in order to find the food. The same approach, we will use it to solving the shortest path problem. There is different path here. For example, the path on the right, on the left, we find it's taking 4 minutes. The other path on the right taking the 5 minutes. In the optimization respect, we select the 4-minute path because it's the shortest path, or it's the minimum optimal solution we were looking for. Here the pseudocode for the ant colony. I will not go in depth in this part, but in general we have the installation for the trill for a pin. This is it's one parameter used in the ant colony, and we run the algorithm until we meet some condition. We apply some local search, and we update the propane every iteration until we find our solution or meet or run the number, a specific number of iteration. Here we have the simulation for the searching for the sorted path. We running for a number of iteration, and we find in the optimal solution, we find it in the iteration number 2050. Every time we trying to find the shortest path, and every time we are trying to improve the solution until we find the best solution. Now I will talk about particle swarm optimization. We mean particle swarm is also mimic for the natural swarm. a fish sperm or the fork. This is famous. The BSO is this famous method usually apply. It's proposed by James Andrews Eberhardt in 1995. The individual usually interact with each other and trying get learning from the experiments, and this learning help finding or moving toward our objective. It's very easy to implement this kind of approach, and it's very effective and very successful to find the optimal solution. Based on the this BSO, we trying to make some simple rules in order to find our optimal solution, and we use this approach usually to model the human social behavior. The pseudocode of the BSO, usually we have a population of the bird or population of the fish, and we trying to populate involve this population. We generate our population or the next generation. We update velocity and the position every time of the bird or of individual, and we repeat this process until we meet the some criterion, and by end of this run we find our near optimal solution. Moving, we have simulation for the BSO when running. We're looking for the maximum objective value. So we see the during the runtime, we trying to improve our solution, and we until we find the optimal solution or global optimal solution. Now I will move to talk about genetic algorithm. And by the name of genetic algorithm, we mean we apply the genetic concept to solving optimization problem. So the genetic algorithm is the search heuristic, usually inspired by Darwin theories of the natural evaluation. So the algorithm reflects the process of natural selection. We're trying to find the fitness individual or the fitness survivor concept. Based on this concept, we select or reproduce the best or the fittest individual in order to generate the next generation. We apply some genetic operation, which is a crossover, mutation. Usually crossover conduct between two individual or two chromosome, and the crossover mutation apply in only one chromosome. We flip up one gene in order to find a best solution. This is an example about how to represent our solution. So usually we represent it as a gene. So when trying to solve any optimization problem using genetic algorithm, is very, very important how to represent our individual, how to present our solution. So this is different. It is a different kind that is usually used to present solution. It depends on the nature of the problems. Sometimes represented by binary 0, 1, sometimes represented by real numbers, sometimes represented by there is many different kind of representation. As I said, depend on the problems. So what is the national nature selection of process in the genetic algorithm? Usually starting, as I said, to select the fittest individual from population of individual. generally we can generate the population, initial population randomly. Then we need to produce the next generation or the offspring by inherit the characteristics of the parent, and then adding the fitness individual to the next generation. If the parent was better fitness, then we also move to the next generation. Always the fitness is survivor. This process will run in iterative approach until we finish the number of generation and find the optimal solution. We consider, as I said, a set of solution. We have to be very careful with the representation of this solution, and we apply the 5 main bases. Initial population, as I said, we generated randomly. Then we have to formulate our fitness function or objective function. This is usually formulated mathematically and depend of our objective. If we have 2 or 3 or multiple objective, we apply the selection process and the genetic operation, which is crossover and mutation. Here the pseudocode for the genetic algorithm. We install the population, and then we evaluate based on the objective function or fitness function our individual. Every individual in the population we must evaluate. Then based on the evaluation values, we apply the selection. If we apply a maximum, we address maximum optimization problem. So we select the value with the maximum, the individual with maximum value. If our problem is a minimum optimization problem, so we select the individual obtain the minimum values. Then we apply the crossover and mutation operation for the diversity of search, and we at the end of after we applying the genetic operator, we apply evaluation again to because we generate new generation. We have to evaluate the new generation in order to going again to selection process. This process repeat for a number of generation. And the end of this generation, we find our optimal solution. Okay, now I will move to talk about the application. In the previous slide, we talked about the methodologies based on AI. So what the potential application? Actually, we have a huge number of applications for the optimization problem. As I said, optimization problem, find it in everywhere in our life. It can be applied in industry, it can be applied in hospital, it can apply in healthcare, it can apply in the education, it can apply in many sector. We can apply the optimization problem. In this slide, I will give a read word application. Actually, this is application is already presented in a paper by me and other authors, submitted, published in 2014 and 2015. We solving a multi-objective problems for the fecal crash Wharton's design. And we are trying in this design to solving 3 objectives. And minimize the deformation result from the accident, and trying to improve the mass of the fecal. So the multi-fecal crash is, as I said, we're dealing with 3 objectives. The mass of the fecal trying to be maximized, the acceleration of the speed, inclusion of the car, we have also carrying this another objective, and the end of the car also, this is another objective. We have the 5 variables using in the design of the model, T1 until T5. When we run the AI based multi-objective hyperheuristic optimization method on to solving the problems, we find this is solution. Actually, the solution was very promising, and we getting the good result after 3,000 to 750 generation. Uh, in this figure, we have 50% attempted server for the solution that we obtain. From this study, we demonstrate that the optimization AI-based is very powerful method to solving the optimization problem, whatever single or multiple or many objective. Now I will moving to talk about recommendation and potential research area, and I'm so actually I'm caring about this part because as I said, optimization problem although is very useful, but usually many researchers tend to apply another AI methodologies, and they missing the importing of optimization methodologies. So this is opportunity for me to highlight this shorting and encourage the researcher to conduct more research in this potential area. Based on the Saudi Arabia Vision 2030, in order to activate the role of science and contribution with development of Saudi Arabia. So the AI and optimization research must be activation in Saudi Arabia and bridging the gap between the real-world optimization problem and the other sector, including industry and government sector, by adopting a new AI-based technique. So we can conduct this objective by solving the reward optimization problem in Saudi Arabia in device field, as I said, including a hospital, education, factory, and any others. Also by investigation and develop new AI-based optimization method, and apply this technique to solving the real-world optimization mentioned previously. Also, we have another potential research area, which is integrate the AI-based optimization method to some classification method usually used in the machine learning for prediction and detection. And I read some paper and some study already propose they integrate some optimization method with the machine learning in order to optimize get optimization parameter or to reduce the number of features in the selection. And this is really a promising trend of research. Also, a combination of different optimization AI-based method to improve the result and enhance the performance at all. Some very state-art technique, which call it hyperheuristic. It is promising technique, can be adapted in with the machine learning technique. Some of them as reinforcement learning to improve the learning process and to improve the optimization method performance. It was my talk. Here the list of reference mentioned in all the talk. If you wanted to go further, I recommend it to go to one of these reference. Here, my publication, and this is the real example what I presented in this slide, in this reference. Thank you for listening, and hopefully I covered the most important part in this talk. So if you have any question, you are more than welcome. Um, Anyone, you have any question? So I'm listening.
Thank you very much, Dr. Mashaael, for your presentation. What do you suggest in what area optimization problem for research would be more valuable to start with?
Sorry, doctor, I couldn't hear you. Could you say again your question? Could you repeat it, please?
You mentioned several areas
Mhm.
for optimization to be implemented. Your recommendation for the best area to start with in the kingdom, what would it be?
Okay. This is very good question. Actually, it's really hard to answer the question specifically, but maybe I can just in briefly. I said we have with the vision of 2030, we have a lot of opportunity to apply the optimization AI based on it. One of them is the transportation, for example. One of them, the scheduling or the networking. We have a lot of feed also. We have a really big project in Saudi Arabia. We can apply many optimization problem to solving the problem arising when trying to implementing this project. So it's a very wide domain, and the answer is difficult to be. Mm.
Thank you. Thank you, Doctor.
Welcome. So we have any question, or we can conclude our talk? Okay, thank you very much, everyone, and thank you for listening and for attention. And hopefully, we get useful from my talk. And I will I will ending my talk by congratulations to the King Salman and Prince Mohammed bin Salman and all the Saudi population for the Saudi National Day. And may Allah keep this country safe and help all the people to improve this country and keep our king and our Prince Mohammed bin Salman in safe. And thank you very much for everyone.
Thank you so much, Dr. Mashaael. Thank you so much for your speech. Our next session will be at 11 o'clock. I request all our attendees to join us there. Thank you so much.